Lesson: AI for automation and incident response. Artificial intelligence has emerged as a transformative force in enhancing cybersecurity, particularly in the domain of incident response. The integration of AI in incident response processes leverages machine learning, natural language processing, and other AI techniques to detect, analyze, and mitigate security incidents more effectively and efficiently than traditional methods. This lesson delves into the application of AI for automation in incident response, outlining its significance, the underlying technologies, and its impact on the field of cybersecurity. Incident response is a critical function within cybersecurity that involves the identification, investigation, and remediation of security breaches or attacks. Traditionally, this process has been labor-intensive, requiring significant human intervention to analyze logs, identify threats, and respond to incidents. However, the increasing complexity and volume of cyber attacks have necessitated the adoption of AI technologies to automate and streamline these processes. AI algorithms can analyze vast amounts of data at unprecedented speeds, identifying patterns and anomalies indicative of potential threats. One of the primary benefits of AI in incident response is its ability to enhance threat detection. Machine learning algorithms, particularly those used in anomaly detection, can sift through large datasets to identify deviations from normal behavior that may signify a security breach. For instance, an AI system can monitor network traffic and detect unusual patterns that could indicate a distributed denial of service attack or unauthorized access attempts. These systems are trained on historical data and continuously learn from new data, improving their accuracy over time. Moreover, AI-driven automation significantly reduces the time required to detect and respond to incidents. Traditional incident response methods often involve manual analysis, which can be time-consuming and prone to human error. In contrast, AI systems can process and analyze data in real time, enabling faster identification and containment of threats. For example, AI-powered security information and event management systems can automatically correlate events from various sources, prioritize alerts based on the severity of the threat, and even initiate predefined response actions without human intervention. In addition to improving detection and response times, AI can also enhance the accuracy of incident analysis. Natural language processing techniques enable AI systems to understand and interpret human language, allowing them to analyze unstructured data such as emails, chat logs, and social media posts for indicators of compromise. This capability is particularly useful in identifying phishing attacks, where AI can scrutinize the content and context of emails to detect malicious intent. Furthermore, AI can assist in threat intelligence gathering by scanning dark web forums and other sources to identify emerging threats and vulnerabilities. AI also plays a crucial role in the post-incident analysis phase, where it helps in understanding the root cause of an incident and preventing future occurrences. AI-driven forensic tools can automatically reconstruct attack timelines, identify compromised systems, and suggest remediation measures. These tools leverage ML algorithms to analyze logs and other data sources, providing insights into how the attack was carried out and what vulnerabilities were exploited. This information is invaluable for improving an organization's security posture and preventing similar incidents in the future. However, the adoption of AI in incident response is not without challenges. One of the primary concerns is the quality and reliability of the data used to train AI models. Inaccurate or incomplete data can lead to false positives or false negatives, undermining the effectiveness of AI systems. Therefore, it is essential to ensure that AI models are trained on high-quality, representative datasets and are regularly updated to reflect the evolving threat landscape. Another challenge is the potential for adversarial attacks, where malicious actors manipulate AI systems to evade detection or cause them to malfunction. For example, attackers can use techniques such as data poisoning, where they introduce malicious data into the training set, or adversarial examples, where they craft inputs designed to deceive AI models. Addressing these challenges requires robust defense mechanisms and continuous monitoring to detect and mitigate adversarial activities. Despite these challenges, the benefits of AI in incident response are undeniable. Organizations that leverage AI technologies can achieve greater efficiency, accuracy, and speed in detecting and responding to security incidents. This, in turn, enhances their overall cybersecurity posture and reduces the impact of cyber attacks. Statistics underscore the growing importance of AI in cybersecurity. According to a report by Capgemini, 69% of organizations believe that AI will be necessary to respond to cyber threats, and 64% of those adopting AI report significant improvements in incident response times. Furthermore, a study by the Ponemon Institute found that organizations using AI and automation in their incident response processes experienced a 27% reduction in the cost of data breaches. Real-world examples further illustrate the impact of AI in incident response. For instance, Darktrace, a cybersecurity company, employs AI to detect and respond to threats autonomously. Its AI system, known as the Enterprise Immune System, uses machine learning to understand the normal behavior of users and devices within a network. When it detects deviations from this baseline, it generates alerts and can take automated actions to mitigate the threat, such as isolating compromised devices or blocking malicious traffic. Similarly, IBM's QRadar Advisor with Watson leverages AI to augment human analysts in the incident response process. It uses NLP and ML to analyze security incidents, correlate data across various sources, and provide actionable insights to analysts. This not only speeds up the investigation process, but also enhances the accuracy of threat detection and analysis. The integration of AI in incident response also fosters a more proactive approach to cybersecurity. Traditional methods often rely on reactive measures, addressing threats only after they have been detected. In contrast, AI enables predictive analytics, where potential threats are identified and mitigated before they can cause harm. For example, AI systems can analyze patterns of behavior and predict potential insider threats based on anomalous activities, enabling organizations to take preventive measures. Furthermore, AI can facilitate continuous monitoring and threat hunting, where security teams actively search for signs of compromise within their networks. AI-powered tools can automate these tasks, scanning vast amounts of data and identifying subtle indicators of malicious activity that may go unnoticed by human analysts. This proactive approach not only reduces the likelihood of successful attacks, but also minimizes the dwell time of threats within the network. In conclusion, the application of AI for automation in incident response represents a significant advancement in the field of cybersecurity. By enhancing threat detection, reducing response times, improving accuracy, and enabling proactive measures, AI technologies provide organizations with powerful tools to combat the increasing complexity and volume of cyber attacks. While challenges such as data quality and adversarial attacks must be addressed, the benefits of AI in incident response are substantial and far-reaching. As AI continues to evolve, its role in enhancing cybersecurity and protecting critical assets will only become more pronounced.